So now that we have completed almost everything of computer vision, so there might be a lot of things. See, the interesting part about this entire field is every time, all the time, what happens is new and newer models keep coming in. You are going to get better models, better accuracy, better ways of performing, faster speed, everything you're going to get. So that is the thing about this field. This whole thing is in a research phase, so you're going to keep getting things over and over again. Okay, so it's impossible for anyone to make you understand all of those, what is happening, what is not happening, right? So I would say even then, depending upon your problem statement, you need to find out what things can work, how they can work and everything. Okay, so but overall we can say we have completed almost everything, all the main parts that we have of computer vision. Now what we will be doing next is basically starting our next part. So see here, right now what we have done is neural networks. We talked about the basic neural networks, multi-layered perceptrons and everything. Next we talked about computer vision models, right? So we talked about CNNs and everything. Now we will be talking about natural language processing. Okay, so in NLPs what is basically used is RNNs, LSTMs, attention blocks or transformers, and we will be talking about each of them. Okay, but for now, since we are starting NLP, let us understand a bit about NLP. So NLP stands for natural language processing. Now that we know what this stands for, let us now understand what are the different ways how we can solve this, what are the some tasks that we have. See, sometimes you might see in some websites you have automated chatbots, right? So there you can ask questions and you can get instant replies. So that is one of the tasks for NLP. You have text summarization. So a very good example for this could be the news application InShots. So what happens is, see, the whole text, the whole link or the whole article is summarized in less than 60 to 100 words, right? So that is text summarization. In this what happens is they basically identify the most useful kind of sentences and they keep that, the rest gets removed. Even in text summarization there are two different types. We will not be talking about all those, but yeah, we have text summarization, we have question answering, we have language translations. So the tasks related to chatbots can be a lot. Okay, so it's not just this, there can be a lot of things. You can have captioning tasks, you have all those sentiment analysis. So the whole point of this is basically the tasks are a lot. Okay, you can do a lot of things when it comes to natural language processing. In fact, computer vision, more than computer vision, NLP is right now more in market, more in play, and all the things that are being applied to NLP are finally being seen and applied to your computer vision tasks, and they are able to see, okay, so this also works for your CV tasks. So all the traditional models that we were using are kind of not being used a lot now. Okay, the researches are coming up, and as I'm saying this right now, this might be relevant 2 years down the lane, this might not even be relevant. All right, so you have to keep yourself updating because this is a fairly new field and we are having and going through a lot of research at the moment, right? So we'll be talking about natural language processing. Okay, so let us first talk about how we can deal with some normal text, okay, and some ways and everything. Okay, so this is basic processing. See, even if you have text, you have to first process the text. Like, it is impossible to do anything without processing. You need to have clean text, only then can you understand for anything. That is true, right? So we'll be understanding about the first step, which is a text processing. Okay, and we'll see the different ways how we can process the text, different processing methods and everything. Okay, so let us start with the basic thing. Okay, so this is basically a string, and the string has been initialized as data, and it has been initialized in a variable a, and then we are printing out the variable to see if this is running or not. Okay, so this is a string, and these types of strings will be used for our tasks in NLP. Next, what we are doing here, we are using the string as an array. So what does that mean? Here you have a string, right? But you can also use this as an array. So what this will mean is basically all this, each and every letter will be a letter in array, okay? So it can be used in that way also. If you run this, see, it gives you the fourth letter. So this is 0, 1, 2, 3 and fourth. So fourth letter is S. So I got S. If I can also do array slicing here. See, after slicing, so you will get everything from the fourth onwards. So you got the whole thing that is left, that is set. Alright, so all the functions of array can also be used here. Next, what we are going to do, see, here this was there, now we are just talking about slicing. You can see here 3 to 6, it will give all the letters from number 3 to number 6th one. So D, A, T, so it will start with the next A, which is followed by a space and then a T, and that is where it will end. So this is your 3 to 6 array slicing, right? In the next way, what we are doing, -6 to -2. So here we are going in the backwards direction. So you have -1, -2, and then, so after -2 onwards, here you have E, T, dash and A. So these three are ones that will be used. So -6 to -6 is basically counting backwards on. So count back till it reaches 6 and then count back till it reaches 2, and that part will be used for your slicing here. And in the same way, here you have slicing but with an increment of 2 letters at a time, okay? So here you have 2, 6 and it will be incremented by 2. So you have 0, 1, 2. So you will have T first, now incremented by 2. So you have A, and then this will be followed by blank space, and then finally you have T, and then you won't be having E because that is your 6th letter. Alright, so you will go through this, you will understand, it's not that big a deal, it's an easy thing, and this was basically just to show that your strings can be used as arrays. Next, you have some string methods that we'll be looking at, okay? So you have split. Split basically what it does is helps you in splitting on the basis of the space here, okay? So space will be used for splitting. You can define the way in which you want to split. So if I give a comma here, and let's say I give a comma here as well. So now you can see it will be split on the basis of this comma. So you have data which is followed by a blank space, then this comma will be used for your split, and everything after that will come here. Alright, so this is basically your split function. Next, you have lower and upper. They are very easy, as the name suggests. What do? They convert any type of string into lower and uppercase. So let's just change this here, okay? So now this is, the whole thing is in capital and small letters. So if you'll see, now the first thing that it will do is it will convert the whole thing into lower. So everything is already in lower except the D, so that converts into lower itself, okay? And then finally the whole thing gets converted into upper. Then next you have replace. So replace, what this will do is basically it will replace one thing with the other. So here let us replace A with me. Alright, so you'll see instead of A we have ME. So now this is no longer data, it becomes DME, TME, okay? Because all the A gets replaced by ME. Now here, see, another thing that we will be doing is splitting here on the basis of let's say a letter. So let's say we have the letter T and we'll be splitting it on the basis of the letter. So if you want to think how will this be, DA, then T will not be there, anything after that. So A and space will be the other token. Next, T will not be there, then it will be EST. Let's look at this. See, DA is there, this will be followed by a T, then it will be followed by an A, then this will again be followed by space which is here itself, then this is a T, and then so on, right? You get the idea. And then again what we can do is, once you have this array, right, you can even join this with letter T, okay? Then here, this is basic normal string concatenation that can be done using your plus symbol. So now two different strings are concatenated. I am pretty sure you people know about all this already, but I am going through this again because see, it is important to understand the different properties of the strings, because we will be using strings in natural language processing a lot. Now here what we are doing is basically opening a text file. So you have a data test.txt file, okay? So we will be opening this. So it is opened. Here what we will do is basically write something in the text file. Alright, so we'll be writing 5 lines in the text file, and it will start from line 1, which will be line number is 1, then line number is 2, line number is 3, and so on. Okay, so this will be basically your whole task of this. So this whole data test .txt, this will contain what? This will contain lines which are from 1 to 5, and it will be written as line number 1, line number 2, and so on. Okay, now after you have done, you can close the file. Okay, this has been closed. Now if you will open the file, you will see it has been written in that manner. Now what we'll do, we'll open the file and check this out. So one thing that you have to see is when you're writing W plus, right? So here you have to give the mode in which you are opening the whole data set. Alright, so if you are opening the data set, so there are a lot of modes you need to understand, right? If you are opening it just for reading, so you can write an R. If you are opening it for writing and for reading, then you can use W plus. If you are using it for appending, use A plus. So appending basically means there is already some data inside your file, but you are adding more data to it. Alright, so you will, for appending, you will be using A plus. So now that is what we are going to do here. So we created the database, the data file, and what will it contain? Like this: line number 1, line number 2, line number is 3, line number is 4, line number is 5. Okay, so this is my text file that I have created. Now I'll be using append function so that I can add another line to it. Alright, so now what we will be writing is basically appending line number, and this will go on from the range to 1 to 3. Okay, so appending line number 1, line number 2, and line number 3 will be added, and finally we'll be closing the file. Now let us open the file again and read the file this time. So now we'll be seeing whatever contents it is having. See, so these are the contents of the file. So here is the output, is basically the print statement. So this is not inside the file technically, and yeah, here this is the whole thing. So you have line number is 1 to 5. This was when we were writing the whole data set, and then we have appending line number 1, 2, and 3. Okay, so this was the extra thing that we did using appending. So one thing you need to remember, if you want to overwrite a file, right, in that case use W plus. If you do not want to overwrite it and want it to be continued from the next line onwards, in that case use append. Okay, go for it. And when you are reading this, obviously you need to make sure that whatever you are using, you understand what it is and you are using it for the task required. So here you have file modes like I was talking about. R is your default mode for reading, W is your default mode for writing. Okay, so if the file exists already, it truncates the file. So truncates basically means it removes the file. So if you already have a file, with let's suppose file.txt, so you have this file, okay, and you want to append more data, in that case never use W, because what W will do, basically overwrite the whole thing. Okay, so whatever data is there will be overwritten. Then X, it already creates a new file. If the file exists, the operation fails. This is not used a lot. A is for opening in append mode. T will be the default text mode, it will be opened. B is for binary files, so there can be files that need to be opened using this B thing. Okay, and then finally plus, this will open a file both for reading and writing. Alright, so that is it. Then we will be talking about web scraping. This we will go in details afterwards. Okay, so we can skip this for now. I'll show all of this to you afterwards. Alright, now we'll be coming, now these were, see, even though we were talking about text processing, right now we just talked about all the string functions, different things the string can do all the properties and everything, we talked about that. Now we'll be talking about text pre-processing. So for text pre-processing, what we are going to do is basically we are going to import NLTK library, string, and RE. Okay, so NLTK library, it is not present by default, so in that case what you have to do is basically download the library. Alright, so to download the library, wait a minute, so here you can download the library from, or you can just write pip install NLTK. So let's add this line also. Okay, since people are not going to have this by default, so let's add this. So you can see, since I already have this in my system, it says requirement already satisfied, but since you will be downloading it for the first time, so in that case the whole thing will take some time to download. Okay, then we'll be importing this. Now what we are going to do is we are going to convert this into lowercase. Now I know it can usually be done using .lower and everything, but here what we are doing is basically, see, Here we are using it inside a function so that it can be used over and over again. Alright, so you can see this was our sentence. It had both capital and small letters. Now the whole thing has come into small letters. Now what we'll be doing, we'll be using something known as a regex library. So regex library or regex expressions, what they are basically are used to match words that are very similar in the way that they have been written. Alright, so let's say you have an email in that form abc@gmail.com, then you have another one xyz@gmail.com. so these two mails, what is similar between them? There is some similarity, right? So you have something w, and then this is followed by @gmail.com. Right, so this is your form of your regex expression, right? You have some words here, or a word here, or maybe you have a group of words here with no space or something like that, and then group of letters here, and then this is followed by @gmail.com. So regex expressions, what they are do help is, see, they help in finding text or strings that are very similar to each other, right? They have a particular pattern, so you can write what pattern you want, and then you can get everything that is related to this. Alright, so here what we are going to do is basically we are going to remove numbers. See, to remove numbers, so if you want to learn more about regex, right, so I would suggest go through W3 schools. So you have the Python regex here, so you can read the whole thing about this, okay, how this is done, how this is not done. So if you want a kind of sentence, every sentence that starts with the and ends with Spain, in that case what will happen is, to start something you will always have this caret sign, alright, and for ending you will have this dollar sign. So this will mean basically it ends in Spain and it starts with the. Then here you have everything, you can read about this, you will understand the whole thing. So you can read about it. Alright, so we are not going to go into a lot of details, but yeah, regex basically means is to find similar pattern of words. So here what we will be doing is removing all numbers. So first we'll have to find all numbers. So that means to find numbers we use this thing. Alright, so to find numbers we use \d. So d basically describes numbers. \capital D means anything that is not a number. Alright, so it is in that manner this is happening. So \d will say anything that is a number. So if you have anything that is number or more than one number, plus means basically if you have more than one digit. So /d will define one digit. If you add plus, that means more than one digit. So if you have more than one digit, then sub basically means to substitute. Okay, so you're going to substitute that digit format into a blank space. Alright, no spaces there, a blank quote, and you will do that in this text file, okay, or text sentence. So what will happen is, you have your input, this is your sentence, you bought 6 candies from shop and 4 candies are in home, right? This is your sentence. So what will happen is, see, 6 and 4 need to be pointed out. So in that case what you will do, you will pass this here. So it will substitute all the digits. So if instead of 6 it was even 64, even then this would work. If you look at it, see, even then this is working because you have this plus sign here. Plus means even there is, if more than one, it will work. So you have this, so it will pass here, so it will go through all the words and everything, and then it will see, okay, so /d represents this and this thing. So I'll remove this with a blank quote here. Alright, so this has been removed, and now you have, you bought candies from shop and candies are in home. So the numbers have been removed. This is about remove numbers. There is another thing that is used. See, there are a lot of libraries. If you will come in Python and understand, you'll see there are a lot of libraries. You can do everything basically with library because there are a lot of them. Okay, so we'll be talking about something known as inflect library. We don't have to talk about this, but yeah, so this basically is used if you want to remove these numbers with some written numbers, right? So in that case what you'll be doing is, you'll be installing inflect first, So my requirement is already satisfied, so it will show me that. And then once you have installed it, you will just write a simple sentence, and in that sentence what you will do is you will just check whether there is any number or not. If there is a number, you will just pass it through inflect engine, which is Q, and then that will convert the number to words. So this inflect has function called number to words, so we'll be passing it and it will convert it into word. Once you have the word, now you can do the whole thing. So what we are going to do is basically split it in the form of spaces, and we'll pass each and every word and we'll check if it has a number or not. Okay, once you have the number, or if it is a number or not. If it is a number, it will be passed through this numbers to word, and this will work. Let us try again 64. See, it automatically changes to 64. So this was one thing. Then let us talk about how to remove punctuations, right? So in remove punctuations, what you have to do is basically in string itself you have string dot punctuation. Okay, so it basically translates string dot punctuation into blank quote. That is what is happening here. So you can also do it in regex. In regex you can do substitute, and what will you be substituting? String dot punctuation, and you will be substituting it with a blank space. So that is it. For now everything has been removed. That means all your punctuations have been removed. See, 2 question marks, 1 comma, none of this is here anymore. So if you run this string dot punctuation, so these are all the punctuations that are used. Okay, now let us talk about removing default words or removing stop words. So what are stop words? First let's talk about. So stop words are words that are going to be used a lot in NLP area. So let us talk about this. So stop words basically means words that needs to be removed. So why do we need to remove words? See, sometimes there are words like a, and, the. We don't need these words because these words are used a lot. Alright, so, and other words, because they are used so much, we do not require them anymore. Let's say he is a boy. Even if you remove a, you will still be able to understand, okay, grammatically it's not correct, but he is boy makes sense. You are still able to understand what the whole sentence means. And these words are being used a lot, hence they are known as stop words. And every time when you are doing any pre-processing task, any cleaning text task, always remove the stop words. It is important because these stop words affect a lot in your accuracy, in the way you are training and everything. Okay, so you need to make sure of that. So we'll be removing stop words. To remove stop words, what we'll be doing is first downloading 2 things. We'll be downloading stop words, because see how will we be doing. So NLTK basically is a library. We talked about NLTK, but this is basically a library, and this is helpful for us to do all the pre-processing tasks. So what we are going to do is, with the help of NLTK, we are first going to download stop words. So NLTK already contains the whole list of whatever are known as the stop words. Once it has the list, now what happens is, now we will go through all the words in a sentence. We'll see if there is any word in our sentence that is in stop word. So if there is any word in our sentence that is also present in NLTK stop word library, in that case we will remove that word, or we'll call that word as a stop word and remove it. So let us download this first. It has been downloaded. Next thing what we are going to do is basically remove stop words. See what is happening now. You have stop words here that is being downloaded. So you can just write stop words English. Now it will show all the stop words that are for your English language. Okay, and it forms a set. Word tokenize also, by the way, this punct is basically used for tokenization. So tokenization basically means breaking down all your sentences into words or tokens. So there are a lot of ways in which you can break down a sentence. Some people break down a sentence using the phrases that are there in the sentence, alright, where you have to take a pause. Others might break down the sentence in the form of the number of words. So after every word there is a breakdown. So punct basically is used to tokenize those sentences. Okay, so that is the whole thing about punct. So the first thing that we will be doing is basically tokenizing the words. Alright, so here we are going to remove the stop words. To remove the stop words, first what we are going to do, we are going to import and download the stop words, and then we are going to make a set of those stop words. Once that has been done, all the words will be tokenized now using the punct library, and then it will first be filtered. So in filtration, what will first be removed? All the punctuations will be removed. So now this is your data set. Okay, so this is your sentence. What is the only punctuation? There are two punctuations here. One full stop is here and the other is here. Okay, so what we are going to do is basically remove these full stops. So to remove these full stops, we will be using string dot punctuation. Okay, so if your word, once it has been broken down into tokens, if it is there in your so once it has been broken down, what will happen? You'll have words, and these words, AI, this is a word, and these words will now be separated. Okay, and now once you have these, we'll just go and search for punctuation. If there is any punctuation, remove those. Once that has been removed, what we will be doing is removing words that are from the stop words. Okay, so now you can see here, data is the new oil, AI is the last invention. Alright, so is has been removed, the has been removed. These are the stop words, because here you have data, new oil, AI, last invention. Alright, so here also you can understand data is the new oil, okay, and AI is the last invention. So is and the from data is the new oil, and is and the from AI is the last invention has been removed. So it can change in any way, and even if you have a or an or anything else, even then what will happen is these words will be known as stop words, and they will have to be removed. So how will they be removed? You will have the stop word set, and you will just go and check if that word belongs to the stop words, then remove that word, else keep that word. The next thing that we will be talking about is known as stemming. So there are two things that I'm going to talk about here. Okay, so one thing is known as stemming, and the other thing is known as lemmatization. Now they both are very similar. Okay, so there are chances that you might get confused, but let us talk about those, so we'll be able to understand what the whole thing is about. Okay, so first you have stemming. So there are words you might know that actually come from other words, right? So let's say you have this word boys. Okay, so you know this word has come from the word boy itself. Okay, so you know for a fact, see, these things are data pre-processing techniques, text pre-processing techniques. So we are going to talk about these. So the first thing was removing all the punctuations and everything. Next was removing the stop words. Now what we will be doing is known as stemming. So like I am saying, suppose you have the word boys. This can easily be replaced by the word boy, because this is the actual meaning of the sentence. Okay, let's say you have another, let's forget this, and let's say you have something else. Let's say you have something known as texting. So this itself comes from the word text. So stemming what basically means is, see, even if you have texting or texted or text, they all belong to the same stem, or they all have the same origin, which is text itself, right? So what we are going to do is basically, wherever you have sentences where things are like in a different sense, or they have some other main origin, okay, main branch. So in that case, what we are going to do is convert these into the main branch as it is. So let's say you have something as going here. So this itself is from go, or you have went here. This again is from go, right? So these things will be changed into the original format, which is go. So that is what we are going to do using stemming. Let us look here. Okay, so NLTK again provides stemming. So there are two types of stemming. Again, we are going to do Potter stemming. So if you run this, see, and also there is once you have Potter stemming, and you also have snowball stemming, but Potter stemming is something that we are going to do. So here you have function. In this, what happens is, first your words are tokenized. Once it has been tokenized, you are going to call this stem function, and this stem function, what it will do is, it will convert each word in the words token to the original meaning. Alright, so here you had data is the new revolution in the world. In a day, one individual would generate terabytes of data. So you can see data is the new, instead of revolution, it became revolt. because the whole revolution, revolt and everything, they all mean the same thing. They have the same original word. The origin is this, so it gets converted into this. In the world, and then in a day, one individual is changed to individual, and I don't know what this is pronounced as, would. Instead of generate, it has become gener, terra. So that is what I'm talking about. They get converted into the original sentence. Now we are going to look into lemmatization. See, this is going to get a bit confusing. So sometimes you might have seen, see, revolution changed into something known as revolute, right? We do not know the meaning of revolute, but we know this is the origin word. So this word has come from here, but it becomes difficult for us to understand what the whole meaning is, right? So in that case, the scientists, the researchers have also introduced us to something known as lemmatization. So what lemmatization basically does is, you have these words make no sense. In lemmatization, it will go through this whole thing where words will go back to their original form, but these forms will actually have some meaning to it. So it will not be random, I mean, it will not be origins which you do not understand, it will be origins that you understand. Okay, so let us look into this. So now what we are going to do is, we are going to use WordNet Lemmatizer here, okay, and this is also present in the NLTK library. The whole NLTK library is basically natural language toolkit, so it has all of these already present in it. So we are going to do the whole thing. Here you have lemmatize word, the lemmatize function will be called, and it will be converted into POS speech, parts of speech. So if there is a word that can have two different parts of speech, alright, so in that case it will be converted to verb parts of speech. Parts of speech, you might know all this, right? Sometimes words might have more than one parts of speech depending upon the sentence type. Then you have to understand what it is actually meaning there. Okay, so that is what it is saying, that if there are more than one part of speech, it will be converted into the verb form here. So if we run this, now it is data, instead of is it became be. But if we had applied stop words, right, in that case what would have happened, is and the would have been removed, and there would have no been me. Okay, there would have been no be. So data is the new revolution, so data be the new revolution. See here, this time the word means something, alright, you will be able to understand what it means, even though this might not be the original one, but you can still understand it. In the world, in a day, one, here it became again individual, generate terabytes of data. Right, so this is the whole difference between stemming and lemmatization. They both have the same thing, that is to go to the original meaning of the sentence or the original thing. But in stemming, you do not understand, sometimes you might not understand the original word, but in lemmatization, yes, you can understand the original word and what it means. Alright, so now we have completed this. So now what we will be doing is parts of speech tagging. So in this thing, what happens is, this is also a part of preprocessing. In this, once you have your words converted into tokenizations, so you have all the tokens now. The tokens are basically different words in a sentence, so you can divide it into different tokens. We'll talk about tokens later on in details, but for now, yes, you have tokenization and we'll be using tokens here. Okay, so once you have that tokens, for now let us just simply understand those are simple words. Okay, so you have a sentence, each word in the sentence is your token, that is known as tokenization. That is what we are going to understand here now. So each of the token or each of the word itself is a part of something, that means it is a part of speech, and you might not know which part of speech this is, but in NLTK they have already made this, so you can understand what part of speech it is from. Okay, so you don't have to go and see, okay, R is from here, there, something. You do not have to understand the whole grammar behind it. So the whole thing to do that is basically you have to use the from NLTK import POS tag. POS tag means parts of speech tagging. So it will call this and it will give you all the parts of speech. So R is basically stands for proper noun. So R is a proper noun, U stands for personal noun, IN stands for preposition, and so on. Okay, to get and understand this, I would suggest to go to the pen your bank. Okay, so tree bank here, it has all those short words, and you can see, okay, so you have this stands for either a proper noun or a singular noun. Okay, so in that way what you're going to do is go here and check this out. These are the short forms for the whole thing. Okay, so in that way, now what has happened is basically all your tokens, all your words have been converted into some parts of speech. You are able to get the part of speech, which part of speech it is from. Okay, so here if you want to understand a particular thing, okay, so you do not know what NNP stands for, but you do not want to go and search here also. In that case, what you can do is basically you can use the NLTK.download tag sets. So in this, what it will happen is for each of the small letter it will download a tag set, and then you can use the help. In help, what will happen is, see, if you write PRP, it stands for pronoun or personal, and it represents hers, herself, him, himself, and all these different pronouns. Okay, so this is what basically will help you in this. So if we type something else, let's say we type NNP. So here NNP basically means noun, and it is proper or singular noun. So you have some examples here. Okay, next we will be talking about chunking. So chunking basically means extracting phrases. So chunking is basically used to extract phrases from unstructured text. Okay, so that is what we are going to do using chunking. Chunking, what it does is basically it divides it into chunks based on the noun phrases. So here also again this is present in your NLTK library. So you can divide it into chunks, you can use word tokenizer and everything. And once you have that, what you can do is basically get the tag with it, that means your parts of speech, and that in that format then you can finally parse it through a regex parser and get different chunks of the whole thing. Okay, so you have here this thing is flying in the, so the little red parrot is flying in the sky. This is your whole thing, and your grammar should be in this particular format. So this is how it will show you the whole thing out. Okay, so this helps in structuring out. So if once this has been done, right, you can draw this tree like diagram here. Okay, and here then finally you can see your whole sentence has been broken down into a word tree format. To understand more about chunking, right, I would say not to use NLTK library and use more of Spacey and TextBlob libraries. We'll talk about those also. All right, next we'll be doing named entity recognition. So this basically means is identifying it from the entity that it is. All right, so here you have the sentence. You'll be downloading a chunker, so that means to divide it into chunks. Once that has been done, what you will be doing is basically using POS, that means parts of speech, to you get for the words. And once you have that, you can use that in the chunk, and then you can find NER. NER basically means named entity recognition. So you have the sentence, we'll understand about this. So you have the sentence, Brian Lara scored the highest 400 runs in a test match which is played between West Indies and England. Alright, so in that case you can see it has explained, or it has showed us that Brian is basically a person's name, Lara is also for a person, scored is a verb, DT this is for the, so if we look here, TT stands for determiner. Alright, then highest stands for JJS. So if you will look back here, JJS stands for an adjective. So in that way it has basically divided. So this person here, okay, this part here, this person here, this is a named entity recognition. Then you have West Indies and England. See, West Indies and England have been identified as organization. Alright, so these basically these things, these capital things here, these are your named entity recognitions. Other than that, the other thing, these are basically your parts of speech, the NNP or the VBD and so on. Alright, so you need to understand the difference here. So named entity recognition basically helps in understanding the names or categorizing it into person, organization, event, place, etc. Now let us talk about understanding regex. So I told to read regex from here obviously, so you can do it, but let us just go over this once and understand why we should use regex. And so regex basically, like I said, is able to identify very easily through what you have given, what kind of words you are looking for in a particular sentence. Okay, once that has been done, right, so you will be able to form any regex sentence and be able to identify any particular types of words depending upon the requirements. So let us look here. So you have \d, which represents digit, capital D for something that is not a digit. Then again you have plus, which means it matches one or more. Then you have \s, small s represents space, capital S will represent anything which is not a space. So small and capital basically are just complementary of each other, like in small d and capital D, small s and capital S. Then small w will represent letters, which also includes alphanumeric characters, by the way. Alright, capital W will represent anything that are not letters. Dot equal represents anything, dot represents anything but letters. Alright, backslash b is for new line, backslash b is for any character. So backslash b is for any character. Then you have plus. Plus basically means to match one or more of the same kind. This asterisk means basically 0 or more of the same kind. So let us say you have something like this. Okay, so if I want to match something like this. Okay, so in that case it will also match brain and it will also match brain. Question mark means basically you can have a letter here or you cannot have a letter here. Okay, so but if you match something, if you match it like this, so in that case it will have one more than one or more, right? So in that case it will just match to brain. So this is basically the whole thing. Then you have dollar sign. Dollar sign means the end of the string, it will match to that. Caret means it will match to the starting of the string. Then dash means basically either something before dash or after dash. So if I will write something like this, so this will match both bran or brin. It will not match brain. No, it will not match this. Okay, so this means anything, it can either be A, it can either be I. It will match both in this case. Next you have this thing. This thing basically means this represents two square brackets. Brackets will represent a whole. Let me show you here. So two square brackets means, now this will mean it, I will match with, let's suppose, okay, let me remove this and let us write A to C and then K. So this means it will match with BAK, it will match with BBK, it will also match with BCK. So anything that is lying between A to C, it will match with that. So this is what this range thing means. Okay, now let us look into some of the syntax and understand what is happening here. Okay, so first of all what we are going to do is we are going to use backslash w plus. So the starting of the thing, okay, so in the start it should be with backslash w plus. So if you will run this, what will happen is basically it will match all the letters that are at the start of this sentence. Alright, so you need, so backslash w means any letter, plus means group of letters. So this whole thing basically means a word. So the start of the word, this caret means at the start. So then the space will come. Now the space will not, then again this w will come, but then this will not be used because this is not at the start. So the only thing that we are going to get is the first part, that is the data set over, because that is then followed by a punctuation and space and everything else. We just want a word which, so we just want any kind of expression that starts with a word, so it will just match the first word. Then here what we'll do, you have to split it on the basis of backslash s. Backslash s stands for space, so it will split on the basis of the space and then you will have all these splits. So this is basically tokenization in this case. Next, what is doing, you are splitting but on the basis of a letter. So the whole thing will be split on the basis of S. So you will have V, which is followed by a space, then you will not have the S, then you will have this whole thing till I, and then you will not have the S, then it will be a blank space, and then the whole thing. So if you will see and read this, you will understand this. These are not that difficult to understand. Okay, so even in regex there are three things you can use. You have match, you have search, you have find all. You also have something known as substitute that we did earlier. Okay, so here what we will be doing is matching all the words that start with I and they are followed by, so they are followed by a number of letters. Alright, so we will match that, then it is followed by something that is not a letter, and then again it is followed by I. So what this basically means is these are our options, alright. So what will happen is basically, see, this is matched with these options that we are having here, and then finally you get ice cream comma images in here, right? How is this happening? Let us understand. See, you are matching with a sentence or something, a group of words which starts with I. So all these start with I, okay, they pass, then it is followed by a group of words, sorry, group of letters, that means something. So this is followed by a group of letters, this is not followed by a group of letters, so this automatically gets removed, this is again followed by a group of letters, okay. Then it is followed by something that is not a letter itself. So that means a space is not a letter, so it is followed by a space. This passes, this has already been removed, this also passes because it is followed by a space. Then it is again the next word should start with I again. So here it starts with I, here it starts with P. So this got removed, this is left, so this is your answer. So you got Q, and then what we are doing is splitting it into groups, and then you have the two groups, ice cream and images. Next what we will be doing is we will be searching. So in searching what will happen is basically it will show you whether the particular format has been found or not found where you were searching. So here let us understand. You have the pattern playing and data set. You have the text Raju is playing outside, okay. So what you are going to do is we are looking for playing in this text. Since playing is there, it will say you have found, and since data set is not there, it will say it has not been found. So I am looking for playing in this sentence and it has been found. I am looking for data set in this sentence, it is not found. Then you have re.findAll. FindAll basically means everything, all the matches that are there, you will give me those as outputs. So here what we are finding is basically, see, anything that starts with a W. W means basically anything that starts with W, and it can or cannot have more than one. So backslash dot, then it is followed by @ and then it is again followed by this whole thing. So what this basically means is you have some letters here, one word here, then this is followed by @ then you have another word here. So that is what this whole thing means. So it will match all the @ emails, you can see here. Next we are going to talk about text normalization. So text normalization is basically something that has started because of the lingo that is being used right now, okay. So what that means is some might write okay like this, some might write okay like this, other people might write okay like this. So all these represent the same thing, but they are of different ways in which they are written, they are of different spellings. So what we are going to do is basically do the normalization here. So you can see here the way different people write tomorrow, but it's actually this thing, the way people write before, B and this is followed by a 4, but it's actually BEFORE, right? So these are the different kinds of raw text that is there, and you have to normalize this, okay. So normalization basically is useful when you want to, so you will learn about normalization later on, but what this basically means is, see, it is useful when you have all this. Suppose you are doing some data set on Twitter, okay. So the whole data set is taken from Twitter, so you know that in Twitter people will be using these lingos, these spellings, so you have to normalize this. We'll talk about this later on and we'll see how this is done, but this was one of the ways to tell you how this can be done. Next we will be talking about tokenizers. So we already talked about NLTK, so many things about NLTK we talked about, alright, but we are going to talk more about the tokenizers here. So all the tokenizers for NLTK we are going to talk about it. So the very first thing is to install NLTK. You can install it in this manner. You can write pip install NLTK also, in whatever way you mean to do, okay. So right, it shows the whole thing is downloaded for me, the requirement is installed, and then finally it is making some changes here, but it has been done. Now what we are going to do is we are going to use some tokenizers to understand how this works, right? So what we are going to do is, first of all, so we're going to start with the first, which is word tokenize. So word tokenize, what it will do is basically you will also have the words, but at the same time each punctuation will also become a token here, okay. So this is about word tokenizer. So here you had this whole sentence here, and you had to tokenize it, and you are using word tokenizer, so you'll be forming words, but at the same time these punctuations will also become a token here. So this is basically about word tokenizer. Then you have white space tokenizer. So white space tokenizer is a bit different. So if you look here, now if you look at the tokens, see here, you will see, like you can see here, you have the word, but this time the punctuations do not act as a separate token. So if it is followed by some punctuation, the punctuation will come in the word itself. Okay, so now this becomes a white space tokenizer. So depending upon your task, you might be required to use this, you might require to use something else. You need to know about this. That is the important thing here. So here basically it shows you the length of the tokens, that means the number of tokens that are here, and then you can see that this is all the tokens that are used. The next thing that we can do is basically we can understand about another token, which is the word punctuation tokens. So if you run this, in this case what will happen is, the thing is, it will remain the same thing. It is the same as word tokenizer. Okay, so here also all your punctuations will be regarded as a token. So you can run this here and everything is the same thing. Okay, nothing changes here. The next thing what we are going to understand is sentence tokenizer. So sentence tokenizer, what it does is, it breaks a paragraph into different sentences, and each sentence will be a token. So now words are not token, sentence are token. So here you had this paragraph, it had 2 sentences, right? Founded in 2002, SpaceX mission is to enable humans to becoming a space-faring civilization and a multi-planet species by building a self-sustaining city on Mars. This is your first sentence. The second one is, in 2008, SpaceX Falcon 1 became the first privately developed liquid fuel launch vehicle to orbit the Earth. This is your second sentence. Now the 2 tokens are here. See, this is your first sentence token and this is your second sentence. Then we'll be talking about frequency distribution. So now we'll be talking about frequency distribution. So frequency distribution is basically counting the number of unique tokens and then finding how many times they have occurred in the particular text sentence. Alright, so that is basically frequency, and once you distribute that, it becomes your frequency distribution. The whole downloading thing can also be done using your NLTK. So in this sentence, you have 23 different words and 28 different outcomes. Alright, then you have the frequency distribution. Let's say we take the frequency distribution of person here. So the person was not in this sentence, hence the frequency distribution becomes 0. If I change this word to is, the frequency distribution becomes 1. So there is 1 is in this sentence. In the same way, here you have another important part of this frequency distribution is the keys. So that you can use here. Type words. Also, if you print words, see, now what it has is basically this whole thing where it contains the different tokens. Alright, so here you have the different samples or the different tokens, and that basically will be used to find your frequency here. Now you have it. Now you can print the number of length of words. It becomes 23. Then you can plot it also. So here now you can plot it. So 2, the word 2 appears 3 times in this text. So you have 1, 2 here, to panic, we need to work hard, second 2, and then to ensure self-protection. So you have 3 2s. So that is how you are going to do this, and you're going to understand this is not that difficult. Obviously, it is just plotting out the number of times a particular word appears. Alright, that is the whole thing. Not word, but basically a token, yes. And then you have personal frequency distribution. Okay, so if you want frequency distribution based on some particular way, that also you can do using this. So now if you plot here, this is also one way of doing it. Okay, this is not that important, but yeah, the whole point of this is there are a lot of tasks and things. So right now we have understood of different ways to use the NLTK library, right? So this is an interesting library. We know how to use this. Next we'll be learning about Spacey library, we'll be learning about text blob. So I am going to go over these libraries, and then finally we'll be learning about Stanford NLP library. So we have to go over these libraries, because depending upon where you are working, how you are working, you might require any of these libraries. Some libraries might be good in something, some might not be. So hence you need to know about all these libraries. We'll talk about these. Once we know how the whole text preprocessing part works, right, then we can then shift to our next part. So what will be our next part in that case? We'll be understanding how to model this, or whatever models should we be using for these kinds of structures. Okay, so in text preprocessing, what did we start with? We understood about strings and the different properties of strings. Then we understood about different functions of the strings. Then we understood how to read a file or text format. We then understood about how to remove, how to clean our data, so how you can remove your punctuation, what are stop words. We talked about stemming, lemmatization. Then we talked about how to use parts of speech tagging. We understood about how to use chunking was not that important, but yeah, not in this way, but yeah, in the next later parts in spacey and text block, they are used for chunking and they are very good in that. Okay, then we learnt about named entity recognition, which helps in recognizing whether this helps in recognition whether this is a person or an organization, an event, a place, or so on. Okay, then we talked about regex. We talked about the simple ways how regex is used, where it is used, the different ways to write regex, some syntaxes that are used. Then we talked about the different ways, the different methods of regex. We have split, we have substitute, we have match, we have search, find all, and so many things, and we talked about all those. Then we talked about the tokenizer, different tokenizers, white space tokenizer, normal word tokenizer, and everything. And then finally we came to frequency distribution. So I hope you understood everything. If not, I would suggest to go back. It's not that difficult. Go through this whole notebook. This will be provided to you. You will be able to understand the whole thing. It does not take a lot of time. And if you enjoyed the video, please keep learning and keep reading, and have a good day.